One uses PBr3 and the other SOCl2. And that's going to substitute 1 degree or 2 degree alcohols with either Br or Cl. And if the alcohol is on a wedge, we'll turn it to a dash, and vice versa. And then there's reducing agents. NaBH4 is the mild reducing agent, which will turn aldehydes and ketones into alcohol. And then allyl is strong. And this can turn carboxylic acids, esters, as well as aldehydes and ketones into alcohol. And then oxidizing agents. There's PCC, which is mild, and chromic acid, or H2CrO4, which is strong. And the rules for these are that a 1 degree alcohol with PCC will become an aldehyde. A 1 degree alcohol with chromic acid will become carboxylic acid. A 2 degree alcohol with either will become a ketone, and 3 degree alcohol cannot be oxidized. So if you see a 3 degree, a tertiary alcohol react with either of these, it'll just remain alcohol. top of this part at least. For Grignards, there's 4 different reactions. So Grignard plus a ketone will result in a tertiary alcohol. Second, a Grignard plus aldehyde will give you a secondary alcohol. Grignard plus formaldehyde, which is aldehyde with just 1 carbon, results in a 1-degree alcohol with 1 carbon added to the Grignard, right, from the formaldehyde. And then Grignard plus epoxide, which is this, will result in also a 1-degree alcohol, but this time 2 carbons added to the Grignard, right? Because of these 2. Could I erase this now? And then how to make a Grignard? Is you'll start with the haloalkane and then add magnesium and ether. Good to erase that. So those are all the rules. This is a sample problem. From the previous chapter. chapters, like on the second exam. And then this one is new, right? So, second degree small base, it'll be E2 xyxide. So will the alkene add here or here? Here. And then this one is some addition of OHs across the double bond. And this one we just went over is SN2 reaction of alcohol. And it'll turn a 1 degree or 2 degree alcohol into chlorine. This alcohol is 3, right? So this is gonna stay the same.
Yeah.
And this one's 2. So we'll turn this into chlorine. And as I said, if it's on a wedge, it'll turn into a dash. They erased it. So this one is from before. It's anti-mark addition of OH. So it'll add to the less substituted side. This OH is primary. This we went over is also SN2. Of alcohol. 1 degree / 2 degree alcohol will turn into Br. And then we have a haloalkane. And then we're adding Mg and ether, so it's going to turn into a Grignard, right? And Grignard is so in this case, X is the Br, and we're just adding the Mg. We don't have any R group. So we're just gonna add Mg and keep the Br.
Oh.
Yeah. So this will be the Grignard. And then Grignard plus this is does anyone recognize what it is?
That's a base.
Aldehyde, yeah.
Okay.
So methyl, carbon, hydrogen, and then double bonded up. And as we said, Grignard plus aldehyde will give you a secondary alcohol. How that would work this would attack this carbon,
Okay.
and then that would go there, and it would turn into. And you add this whole part. There, and then there's an H3O plus, right, which can make the O minus into an OH. This is basically the same thing as this, just, drawn a little differently, and then you don't have to include the H, but that's like the mechanism. You don't also have to draw this out for this, but to know how it works.
Can you explain why MGBR acts on a meter file?
It just does, yeah. It's a nucleophilic attack.
Is it like more, is it because bromine's more negative than carbon?
Yeah.
How do we add an extra carbon? Where?
MG is 2 plus.
You go from MGBR to it's just carbon. The last place between.
Here?
Yeah, you went from 2 carbons to
Which charge is plus?
Oh, so this has one carbon here, and then the CH3 has a carbon, right? So, okay. So this is the Grignard, right? So if you don't look at the MGBR, this is adding to here. So this part is coming from here, and that's where the 2 carbons come. So these 2 carbons are here. Does that make sense? So this part was originally from the Grignard, and then these 2 carbons are coming from the aldehyde that has a methyl group as well.
He's doing the one that.
He said he's not doing anything like that.
Yeah, just one thing. He said that he's not gonna do that one on the exam.
He's not gonna do this?
Yeah, yeah.
Oh,
But if you wanna do it,
Because he said that
that was kind of like a little punishment to the class.
So if he's not gonna put, do you guys still want to do it, or should I? skip
Yeah,
it?
because something that I wanna know is like the way how he draw the ketones here is a little different from the previous exam. So I just wanna know why.
Oh, I mean, you can draw this as this as well, which is how we learned in the previous year.
Yeah, but I saw that now he's putting like a different way. Like for
There
example,
is a different way to draw it, but this is also acceptable.
so if you just draw it like that, technically that's fine, right?
Yeah.
Oh, okay. So what?
because he added like an H to the like he added like a little
Yeah, H to the top, but like.
like an
So
aldehyde.
the alkyne is gonna turn into carboxylic acid.
Yeah.
So maybe that's what was different.
Oh no! That part. We know that it's different. No, I understand that part is different. I just.
And then NABH4 is mild reducing.
Mild.
So it would turn only aldehydes and ketones into alcohol. So only these ketones would turn into alcohol. The carboxylic acid wouldn't be affected by the NABH4. It would be affected if this was chromic acid. Or, sorry, lithium, aluminum. So again, from before, this is bulky.
Base.
This is stereo specific, but this methyl has a wedge hydrogen as well, so we can still put it where it would normally go Hoffman. And then this is syn addition across the double bond. And then PCC is mild oxidizing. Where this one is primary, this one is tertiary. So primary with PCC would turn into aldehyde, and tertiary can't be oxidized. So this would remain the same, and this would turn into aldehyde. since it's, there's only one carbon, it'll turn into formaldehyde specifically. And formaldehyde with a Grignard, was 1 degree alcohol with the carbon added to the Grignard. Bromic acid is, so we'll turn the 1 degree into, carboxylic acid. Yeah. Keep 1, 2, 3 carbons.
Could you please explain the first step? Or you got the first?
This up?
Yes.
Yes. So primary alcohol, CH3OH is just this, right? And then PCC is mild oxidizing agent. PCC plus a primary alcohol will give you an aldehyde, but since there's only one carbon in this case, it's specifically formaldehyde. So if it was, it was like this instead, that's still 1 degree, right? With PCC, it would turn into this, right? You would keep the number of carbons the same, and then make it into an aldehyde, right? But for this, since there's only one carbon, it's specifically formaldehyde, which only has one carbon.
Thank you.
I have a question.
Yeah.
So from the second step to the third step, you wrote that, only one carbon is gonna be added, but I see two carbons added.
One carbon's added to the Grignard. So this Grignard has 1, 2.
And then do we add the formaldehyde to that?
The formaldehyde?
To the Grignard?
Oh.
To get that?
Oh yes, let me show it out actually. And then the H3O plus, okay. And you don't have to draw the hydrogens, right? Makes sense? Hold on. Yeah. So this Grignard has 2 carbons,
Mm-hmm.
and then that's here, right? And then we're just adding this 1 carbon.
Okay.
starting is 9 carbons. Wait, 1, 2, 3, 4, and then 6. Or 1, 2, 3, and 6. And then here it's 1, 2, 3, 4, 5, and 6. So 11 carbons. So I want to get rid of carbons first, right? And a way we can do that, we know that if we do a Grignard plus like an epoxide, that adds 2 carbons. And this is a primary alcohol as well, so we could do that in this case. So our Grignard would be here, right? So the alcohol's here, 2 carbons would be here that are added. And then our Grignard would be the rest. So MgBr, and then our epoxide.
Wait,
is
the,
adding the 2
I got a
carbons.
question. The Grignard is always gonna add like 2 carbons?
Not always. If it's reacting with an epoxide, it
Yeah.
will, because these 2 carbons will add.
Okay, so it's just gonna do that when it's reacting with that, right?
Yes.
Okay.
How do we know it's reacting with the
Because you wanna
epoxide, something like that?
We're
technically,
drawing this up. It's synthesis.
technically because you know already that you wanna lose those 2 carbons.
Always starting over.
That's how you can
Title 9.
see that right now.
Got it.
Okay, I guess.
So
And then how do we make a Grignard? It was haloalkane with Mg and ether, right? Mg, ether. And then this will just be Br. And then from before, we know to make a haloalkane. Yeah, sorry.
Instead of like the epoxide, can we just like add like an aldehyde?
Aldehyde. An aldehyde in a Grignard would make a 2-degree alcohol. And in this case, it's primary. Yeah. Yeah. So I'll also be like make a note of what degree the alcohol is. And then to make the haloalkane alkene, you want to work towards that way. It's here. So we added anti-mark, HPO, and then how do you make a alkene?
that's
Alkene.
Volcanoes?
That's looking closer to our original, right? And in this case, Hoffman, so we can add both of these. And then to get a secondary alcohol substituted with the Br, so that's the SN2 reaction with PBr3, right? And that's all for this one.
I got a question. In case it was like, for example, like a primary alcohol or a tertiary, how it would change that question, like for the next step?
For this step,
Yeah.
if it was primary,
Yeah.
it would still work, right? Because PBr3 can work